So in this video, we're going to look at empirical formula, which is also part of the calculations topic and can come up on paper 1 or on paper 2. This video is going to be a little bit longer than the others because there are 3 types of questions you can be asked on empirical formula. You can get a simple 1-mark question, a kind of a longer calculation style 4-mark question, or you can get a 6-mark question on an experiment to calculate empirical formula. So I'm going to go through all of those types of questions in this video, which is why it's a little bit longer. The first part, the simple kind of 1-mark question, is just converting molecular formula into empirical formula. So just to explain the difference, the molecular formula tells you exactly how many atoms are present in a molecule. So the first molecule I've got here is called hydrogen peroxide. I can see that I've got 2 hydrogens and 2 oxygens in a molecule of hydrogen peroxide. If I look at water, I've got 2 hydrogens and 1 oxygen in a molecule of water. The next one, which is called ethene, I've got 2 carbons and 4 hydrogens in a molecule of ethene. Molecular formula, exactly how many atoms are in the molecule. Empirical formula, as I've written above, is the simplest whole number ratio of the atoms in a substance. So you need to look at the numbers present in the molecular formula and simplify. So the 2 numbers I have got in the first formula is 2, and I need the largest number that divides evenly into 2. Okay, the largest number that divides evenly into 2 is itself, and if I divide across by 2 and rewrite the empirical formula, I now have H and I have got O. So 2 divided by 2 is 1. So I've now just got 1 after the hydrogen. 2 divided by 2 is 1. I've just got 1 after the oxygen, but I don't need to include those ones. If I look at the next one, H2O, I've got a 2 after hydrogen. I've got no number after oxygen, which implies that you've only got one of them. So I've got a 2 and I've got a 1. What is the largest number that divides evenly into 2 and into 1? Well, it's actually just 1 itself. And if I'm dividing across by 1, I end up with the exact same empirical formula as molecular formula. And that can happen. Sometimes you cannot simplify it down into a simpler whole number ratio. The next one, I've got 2 and I've got 4. The largest number that divides evenly into 2 and into 4 is 2. For the carbon, it's going to be 2 divided by 2 is 1. For the hydrogen, it's going to be 4 divided by 2 is 2. And I end up with CH2. The next one, C3H6. The largest number that divides evenly into 3 and into 6 is 3. 3 divided by 3 is 1. I'm just not going to write the 1. And 6 divided by 3 is 2. So you can see that the empirical formula works out the same for 2 different molecules, but that's okay. The next one, C5H12. The numbers are 5 and 12. Is there any number that divides in evenly to 5 and 12? No, okay, it's just 1. That means it stays the same as C5H12. Pause the video, do the remaining 4 yourself, and then press play again. Okay, so I've done the answers. It's just the last one that I'm going to actually go through with you. You've got 3 numbers here, 3, 6, and 2. The only number that goes in evenly to all 3 numbers is 1, okay? So I'm going to end up with the same empirical formula as my molecular formula, okay? These are just 1-mark questions. You look at the numbers in the molecular formula, you divide across by the biggest number that goes in evenly, and then you rewrite your formula using the simplest whole number ratio in your formula. So that's the 1-mark question. You can also get 4-mark questions on empirical formula, and these are calculation style questions. And in these questions, you will be given the names of the elements in the reaction and the mass of the elements that you started with. So here I've got sodium and I've got chlorine. I'm given the mass of these elements, and I'm asked to use this to calculate the empirical formula of sodium chloride. So I always do this by drawing out a table. And in the top row of my table, I put the names of the elements from the question, so sodium and chlorine. In the second row of my table, I take the mass from the question, so 4.6 of sodium, 7.1 of chlorine. The third row of my table, I take the atomic mass, and I get this from the periodic table. So if I look at my periodic table, the mass of sodium is 23, the mass of chlorine is 35.5. Typically, you don't even have to look at your periodic table. Typically, they will give you these numbers in the question. The next row, I'm going to divide my mass, which is my top row, by my atomic mass, which is my second row. So here I would have 4.6 divided by 23, and over here I've got 7.1 divided by 35.5. And when I do this, I end up with, actually I don't know what I end up with, so I got 4.6 divided by 23, I end up with 0.2, and for the other one I also end up with 0.2. These two numbers here, at the moment, both contain decimals. I need to get those numbers into whole numbers, and I need to maintain the same relationship between the two numbers. So to do this, the easiest thing to do is to divide both of your answers by the smallest answer. Now, in this case, both of my answers are the same. So I'm going to be dividing 0.2 by itself twice, and I'm going to get the ratio 1:1. Okay, my ratio is now 1:1. I can then use this whole number ratio to write my empirical formula. The symbol for sodium is Na, and I've got 1 Na. The symbol for chlorine is Cl, and I've got 1 Cl. So my empirical formula is NaCl. Now you may ask, you can work out the formula of sodium chloride just using charges on the ions. So this is something you would have done in a different topic, where you use the charges on the ions to work out the formula of sodium chloride. And you might be able to quickly work out that it should be NaCl. But if you're given a question like this, they want to see you use the numbers in the question and work it out mathematically. So you have to show all of your working, how you use these numbers to end up at NaCl. I'm going to do another example. This time, the elements I've got are zinc and chlorine. From the question, I can see I've got 10.40 grams of zinc, and I've got 11.36 grams of chlorine. So I fill that into my top row. The next row of my table has come from the periodic table. This is the mass number from the periodic table. In the third row, I'm going to take what's in the top row, 10.4, and divide it what's in the second row, 11.36 divided by 35.5. Okay, so just as I did above. When I do this, 10.4 divided by 65, I get 0.16. And I know doing the other one, I'm going to get 0.32. So these are the two numbers that I've got. Again, these two numbers have decimals. I need to get rid of those decimals, and I get rid of them by dividing both answers by the smallest answer. Now in this case, my answers are different, so I need to look at them and see which is smallest. 0.16 is smaller than 0.32, so I end up with 0.16 divided by itself, and I get 1, and then I do 0.32 divided by 0.16, and I get 2. Okay, so I take both of my answers, and I divide by the smallest answer, which is 0.16, and I get 1:2. I then need to turn this into a formula, so you can see that you have got 1 on the zinc side, so the symbol for zinc is Zn, and I've just got 1 of them. For chlorine, the symbol is Cl, and I have got 2 of them, so it becomes ZnCl2. In the next example, I've got 3 elements. It doesn't change how I do it. I approach it in exactly the same way. I write the names of those elements at the top: copper, sulfur, oxygen. I fill in the mass from the question: 19.05 grams. Sulfur, 9.60 grams. Oxygen, 19.20 grams. The second row is again going to be from the periodic table, and again, typically you're given those numbers in the question so that you don't have to go looking. Once I've done this, it's going to be 19.05 divided by 63.5. So I'm going to divide the top number by the bottom number in all 3 cases. And when I do this for the first one, I get 0.3. And for the second one, I'll be doing 9.60 divided by 32. And I'm also going to get 0.3. And for the last one, it'll be 19.2 divided by 16. And I get 1.2. So again, I've got 3 numbers, and I've got a decimal place in each I need to get rid of those decimals. To do that, I divide answers by the smallest answer. So I've got 0.3 and I've got 1.2. 0.3 is the smallest, so I divide everything, 0.3 by itself. I divide 0.3 by itself, and then I do 1.2 divided by 0.3, and I get 4. I've got 1 copper. Copper is a symbol, has a symbol Cu. 1 sulfur, S. 4 oxygens, O4. Make sure you double check your periodic table when you're writing the symbols. If, for example, you thought that the symbol for copper was CO and you wrote COSO4, you would lose the 4th mark because you haven't written the correct empirical formula. So don't just guess and don't just assume you know. Double check on your periodic table to make sure you've written the symbols correctly. I'm going to do one more example with you because this one is slightly different. In this case, instead of giving you the mass in grams of the elements, they've given you percentages instead. This does not change how you do it, okay? The elements I've got are iron and oxygen, so I'll write them in my top row. And now, instead of writing in grams, I'm going to have percent, but I just write that number in exactly as I did before. Okay, the 70 goes in the top row, the 30 goes in the top row for the oxygen. And then my second step is the same. I divide by my atomic mass. So it's going to be 70 divided by 56, and I get 1.25. And then over here, it's going to be 30 divided by 16, and I get 1.875. So they are the two numbers that I've got, 1.25, 1.875. I need to divide both answers by the smallest answer. 1.25 is the smallest, so it's going to be 1.25 divided by 1.25 equals 1, and then 1.875 divided by 1.25, and that actually equals 1.5. So every other example we've done, when we do this step, we always ended up with whole numbers. We got rid of our decimals. But over here, I still have a decimal. I've got 1 and 1.5. So what am I going to do? I cannot write a formula using decimals. I have to have whole numbers. So I need to get rid of this decimal point. 0.5 is a half. I need to make a half a whole number. So I ask myself, how many halves are in a whole? The answer would be 2. Which means if I multiply this by 2, I'm going to get rid of that decimal. 1.5 multiplied by 2 equals 3. But I need to maintain the same relationship between those two numbers. If I've multiplied the 1.5 by 2, then I also have to multiply 1 by 2. And now I have got two whole numbers, but I've maintained the same relationship, the same ratio. So I started with 1 is to 1.5, now I've got 2 is to 3, okay? And they're the numbers that I'm going to use to write my formula because they have to be whole numbers. The symbol for iron is Fe, and I've got 2 iron, so it's Fe2. The symbol for oxygen is O, and I've got 3 oxygens, so I'm going to write O3. I want you to have a go at these 4 questions yourself. You're going to need to draw out your own table. You don't need to be writing this, okay? That's just to show you what you put in each row, but you can just write out the name of the element on top, the numbers underneath. Keep it nice and organized so it's clear, so your working is nice and clear. As you'll draw out those tables for yourself, do 5, 6, 7, and 8. Be aware that in 8, you're also going to encounter this 0.5 and you're going to have to get rid of that 0.5 in exactly the same way that I've done above. Also, when you're doing these questions, please don't round too early. So when you're on this step here, if they give you an answer to 3 or 4 decimal places, then keep it. Keep it to 3 or 4 decimal places until the very end. Don't round to just 1 decimal place at this point because you can end up getting the wrong answers, okay? So keep them to 3 or 4 decimal places until the very, very end. Press pause, have a go. It's so important that you practice this yourself. Press pause, have a go, and then press play when you're ready to see the answers to these 4 questions. Okay, so here I've got the answers, all right? This is the first one. Carbon and hydrogen, put in the mass, divide by the atomic mass. These are the 2 numbers that you should get. Divide both answer by the smallest, so 0.714 is smaller, so I divide both numbers by 0.714. I simplify that ratio to 1 is to 2, and then my empirical formula is CH2. So you get 1 mark for each of these answers in red, 1 mark, so that's 2 marks in total, 1 mark for the whole number ratio, and then a final 4th mark for writing the formula. The next one, you've got 3 elements, but I approach it in the same way. And again, I've got percentages, but it doesn't change how I do it. So I'm going to be doing 22.24 divided by 12, 3.71 divided by 1, 74.05 divided by 80. These are the 3 numbers I get. Of these, 0.9 is the smallest, so I divide all numbers by 0.9, and I get 2 is to 4 is to 1. So that's C2, H4, and then bromine is Br. Again, make sure you know your symbols. The next question was a little bit different because I gave you the mass of lithium and the mass of carbon, but I didn't actually give you the mass of oxygen. You had to calculate that. So you were told that the total mass of the reactants was 14.8. You were told how much lithium you had, how much carbon you had. So if you take the mass of lithium and carbon away from the total mass, you will find out how much oxygen you have, and it's 9.6 grams. So once you know that, you can put all of those numbers into the top row. Second row, again, the numbers from the periodic table, and then I divide 2.8 divided by 7, 2.4 divided by 12, 9.6 divided by 16. These are the 3 numbers I get. 0.2 is the smallest of the 3. I divide everything by 0.2. 2 is to 1 is to 3. Li2CO3. The last one, sodium, boron, and oxygen. So again, you've got percentages. It doesn't change how you do it. You divide the percentage by the number from the periodic table, and you get the following numbers. So it didn't go in exactly evenly, but you got 0.99, which you can round up to 1, and 1.98 you can round to 2. But 3.46, you can't just round that up or down to make it a whole number, okay? It's going to be 3.5, so you do still have your decimal place and you need to get rid of it. Because it's a 0.5, I'm going to multiply by 2 because 2 halves make up a whole. So by multiplying 3.5 by 2, I turn it into the whole number 7. But if I multiply 3.5 by 2, I have to multiply everything by 2. And I end up with a ratio of 2 is to 4 to 7. And then I've got Na2, B, boron is B, so bromine was Br, up, we saw that above, but boron is just B. I've got 4 borons and I've got 7 oxygens. So I've written here multiply by 2 to remove the 0.5. So they are all done in the same way. Usually they will go in nice and evenly and you will get those whole numbers straight away. If you do end up with a 0.5, just multiply by 2 to get rid of the 0.5. Okay, so the last thing that you can be asked on empirical formula is about how you would determine empirical formula experimentally. So what experiment would you need to do to find the empirical formula of something? So if you remember from the above questions, you were always given the mass of each of the compounds. So if you were to do this experimentally, you would just need to record the mass of each of these elements at the start of the experiment. And the one they typically ask you about is the reaction between magnesium and oxide to form between magnesium and oxygen to form magnesium oxide. They're going to ask you, how would you do an experiment to get the empirical formula of magnesium oxide? So if I wanted to do this, I would need to know, if we see from the calculations above, I would need to know the mass of magnesium and I would need to know the mass of oxygen. So the first step in your answer would be just saying that you record the mass of a piece of magnesium and then you add it to a crucible. So if I want magnesium to react with oxygen, I need to heat the magnesium. And when I'm heating the magnesium, I put it in a little kind of a pot called a crucible, and then I heat the magnesium. So let's say, for example, I got a piece of magnesium and it was 2 grams. So I put 2 grams of magnesium into my crucible and then I heat it strongly. Heat the crucible with a strong flame and I lift the lid occasionally to allow the oxygen to enter. Now you might ask, why do I have a lid at all? Why don't I just heat it freely? This reaction, it can actually be quite violent, and the magnesium glows really brightly as well, which can be damaging to your eyes. So you have the lid, A, to kind of protect your eyes, you don't have to stare at the magnesium directly, but B, to control the amount of oxygen entering the crucible so that you can control the reaction. So as you lift the lid and allow the oxygen to enter, that will cause the magnesium to react, magnesium reacts with the oxygen. And when magnesium reacts with oxygen, it forms magnesium oxide. Magnesium oxide. Now, I need the mass of the magnesium and the mass of the oxygen. I was easily able to get the mass of the magnesium. I just recorded it at the start of the experiment. But how am I going to calculate the mass of the oxygen that has reacted with the magnesium? It's just the oxygen from the air. It's not a specific amount of oxygen that I'm adding to the magnesium. So how am I going to find that mass? Well, if you think back to the law of conservation of mass, it states that the total mass of the reactants has to equal the total mass of the products. So if I just, at the end of the experiment, get the mass of my product, I can then use that to find the mass of the oxygen that reacted. So let's say, for example, that we started with 2 grams of magnesium, and at the end, we see that we have got 3.5 grams of our product magnesium oxide. Well, then that must mean that the mass of oxygen, to go from 2 to 3.5, the mass of oxygen must be equal to 1.5 grams because of that conservation of mass. So now I know how much magnesium, 2 grams, how much oxygen, 1.5. Because I've got that information, I can then just calculate the empirical formula just like we've been doing, okay? So I would take the mass, I would divide by the atomic mass from the periodic table, and once I've done that, I simplify the ratio to find the empirical formula. So those 6 steps that I've written out, if you were asked to describe an experiment, they are the 6 steps that you would need to describe. Sorry, just to point your attention to number 3, stop heating when all the magnesium has reacted. How would you know? It will stop glowing. The magnesium will stop glowing when it has fully reacted. So I've got some practice questions. The first few I'll go through with you. What element does magnesium react with when it's burned in air? It's not enough to just say it reacts with air. You have to say it specifically reacts with oxygen. And when it reacts with oxygen, you are going to form magnesium oxide, which has the formula MgO. I want you to do question 3, 4, and 5 yourself. Have a go. So I've told you how much magnesium you have. I ask you to calculate the amount of oxygen using the total mass at the end. And then once you've got the mass of the magnesium and the oxygen, you can then calculate the empirical formula. So question 3 and question 4 are the same. And for both questions, you should end up with an empirical formula of MgO. In question 5, I just want to know why the student lifts the lid. And in question 6, that would be rewriting those full 6 steps that I showed you on the video. So if you want to, you can rewind and then write those steps out so you've got them all in one place. But have a go at questions 3, 4, and 5, which are based on empirical formula again. All right, I've done out the answers. So in question 3, you were told that you started with this much magnesium and you made this much magnesium oxide. By taking the final mass and subtracting the mass of magnesium, you will find the mass of oxygen. So 0.96 minus 0.576 is the mass of oxygen. Once you know the mass of magnesium and the mass of oxygen, you can find the empirical formula. So I'm drawing my table, I'm filling in the mass of each. Then I write in the number from the periodic table, 24 for magnesium, 16 for oxygen. I divide, so 0.576 divided by 24, 0.384 divided by 16. You'll see I get the same number each time. To simplify this, I divide by itself and I end up with 1:1, which is MgO. The next question is the same. Start off with 2.4 grams of magnesium. I make 4 grams of magnesium oxide. Therefore, I must have 1.6 grams of oxygen. Divide my mass by my my atomic mass from the periodic table. I get 0.1 to 0.1 as a whole number ratio. That is 1:1. So my answer is again MgO. It should always work out as MgO. Why do you need to lift the lid? To allow oxygen to enter so that the oxygen can react with the magnesium. But you do keep the lid on so that you can control the reaction. If you did answer question 6, describe an experiment that would enable you to determine empirical formula, including measurements. You would need to write out the method that I went through. So record the mass of a piece of magnesium. That would be one of your measurements. Then heat. Even if you didn't mention the crucible, if you just mentioned that you heat the magnesium strongly so that it can react with oxygen. And then once you've finished your reaction, you'll get the mass of your magnesium oxide, subtract the mass of magnesium from the mass of magnesium oxide. That enables you to find the mass of oxygen, and then describe how you would carry out the empirical formula calculation. So you divide the mass by the atomic mass and then simplify the ratio to find empirical formula. So that's how you would answer that final question. So, you know, quite a few questions they can ask you on empirical formula. Those simple 1-mark questions, those kind of table style questions, which is the most common way they ask about it. But you can also be asked, you know, a 6-mark question about the experiment.